Hello everyone, I am Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on some problems on a transformer. First problem here. Calculate the pitch factor under the given winding conditions. So first here 36 stator slots and 4 poles and coil span 1 to 8. And next second problem, same thing here, pitch factor for 72 stator slots and 6 poles and coil span for 1 to 10. And next third problem, 96 stator slots and 6 poles and coil span 1 to 12. So first draw the 3 coils span. So this is 180 degrees case. This is 10. So now here, so 36 slots here, 36 slots and 4 poles. So 36 slots per pole is 9 here. So 1 to 8 here. So 1 to 8 here, up to here 1 to 8. So coil span here. So now for this case here, so coil span falls by here short pitch, but that value equals total 180 degrees for full pitch. Here 2 by 9 here, 2 by 9. So that equals 2 by 9 into 180 into 100, that equals to 40. So now here Kc equals to 40 cos of Kc equals to cos alpha by 2. So here alpha equals to 40. Now if you substitute in this, you will get cos 20 equals to 0.94. And here alpha equals to here, next case here this one equals to total 1 to 10 means here this one 3 by 12. So here in this case 3 by 12 means here next here 3 by 12 means this value is alpha equals to 45. So cos alpha by 2, that value equals to 22.5. Here 5 by 16. So 5 by 16 means this value equals to 56.6. That value equals to cos alpha by 2, cos 56.16 divided by 2, that equals to 28.8. That equals to 0.0882. So now second problem. So calculate the distribution factor KD for 36 slots, 4 poles and single layer 3-phase winding. So now here 3-phase winding means, so number of slots per pole. So N means number of slots per pole. Number of slots are 36. So number of slots and number of poles. So that is N. And next beta equals to 180 divided by number of slots per pole, 180 by 9. So that equals to 180 by N. So that equals to 20, 180 by 9. So now here M equals to slots per pole per phase. Here how many number of phases here? 3 phases. So 3 phases. So now here distribution factor formula KD equals to sin M beta by 2 M sin beta by 2. So this is the formula for KD. Here M equals 36 by 4 by 3. 36 by 4 by 3, that value equals to 36 into 4 by 3, that value equals to 3. So now here this M equals to 3, here M equals to 3 and beta equals to 20, this value, and beta equals to 20. So now if you see the formula carefully here, so this is the formula. So now if you simplify this, that distribution factor KD equals to 0.96. Next problem. A part of an alternating winding consists of 6 coils in series. So each coil having EMF 10 volts RMF induced in. So the coils are placed in successive slots and between each slot and next there is an electrical phase displacement of 30. And find the graphically or calculation EMF of 6 coils. So now if you see the derivation here, beta equals to 30 and M equals to 6. So 6 coils and KD equals to this is. So now here this sine of 6 by 6 into 30 by 2. So now here 3, that is 90, and 6 and sine 15. So sine 30 by 2 means that is 15. This value equals to 1 by 6, 0.2588. So this is one. So arithmetic sum of voltage induced in 6 coil equals to 6 into 10, that equals to 60. So now vector summation equals to this KD into arithmetic sum, that equals 60 into 1 by 6, 0.2588, that equals to 38.64. So now next problem, find the value of KD of an alternator 9 slots per pole for the following cases. So now one winding in all the slot and one winding using only the first one is 2 by 3 of slots per pole, and 3 equal windings placed sequentially 60 group. So now here 180 by 9, here 9 slots for pole, this is n equals to slots for pole, that equals to 9. So here n equals to given. So now here beta equals to 180 by n. So this one. So now 180 by 9 equals to 20. So this is okay. So now for this is for 3 phase, for 3 m equals to 9 and m equals to 6 and m equals to 3. So for this case, so m is the number of slots per pole for phase for 9, 6 and 3. So for this case here KD value equals to beta equals to 20, 20, 20, and this is m, and this one is 6, 6, and this one is a 3, 3 m value. Only 20 beta value same. So for m equals 9 case, KD equals to 0.64 and KD equals to 0.83 for m equals to 6 case, and this m3 equals to 0.96. So now here this is the KD formula. So now next case, an alternator has 18 slots per pole, this is n. So now first coil lies between 1 to 16. Calculate the pitch factor. Same as first problem. So fundamental, for the fundamental, third harmonic, fifth harmonic and seventh harmonic. So first one cos alpha by 2. So 16 minus 1, 16 minus total 15 coils are fall short by 3 slots. So that equals to alpha equals to 180 into, so now 16 minus 1 means that is total how many slots here? 18. So 18 minus 15, that is 3 by 18. So that equals to 30. So cos 30 by 2, that is cos 15, that equals to 0.966. So this one is okay. And now cos KC3. KC3 means here harmonics. Harmonics may you can consider. So here in the fundamental, that is 1. This is same cos alpha by 2, alpha equals 30. Harmonic factor if you consider here 5, 7. So 5, 3, 5, 7. So cos 3 into 30 by 2, that value equals 0.707, and cos 5 into 30 by 2, that value equals to cos 75, that value equals to 0.259, and cos 7 into 30 by 2, that equals to cos of 105, that equals to cos 75, that value equals to 0.259. Same value for this one, KC5 and KC7. This is KC1 fundamental, KC3 third harmonic, KC5 and KC7. So this is one. Next one, a 3-phase 16-pole alternator, that is synchronous generator, has star connected winding. So 144 slots, 10 conductors per slot, and next flux per pole is 0.03 Weber, and next distributed sinusoidally distributed, and speed is 375 RPM. Find the frequency of RPM and the phase and line induced EMF. Assume the full pitch coil means cos alpha only. Now here F equals to, what is the formula for equals to? F equals to 120 F by P. This we know very well, this formula. Ns equals to synchronous speed equals to 120 F by P. Here F equals to N into P divided by 120. F equals to N into P by 120. So this one. Here we know the number of poles here, and we know this speed 375 and 120. So here frequency is 50 Hz. So now here what is the formula actually? So here formula equals to here. So E phase equals to 4.44 KD into KC into F into 5 into and total number of turns. Here this is the formula. Here frequency is over 50 Hz, and next thing here KC and KD. KC is 1. So KC is 1. Full pitch coil. For full pitch coil KC is 1. So this one is also over, and this one is 0.03. This one flux value is also okay. Next thing here, total number of conductors. So T turns here. So 144 turns here, 144 into total here how many 10 conductors, and it is a 3 phase. So total number of conductors here 480, turns here 240. So this is 240 and this is 240. So now here what about the KD? KD can be calculated here. KD equals to sine of m into m into beta divided by 2 and m into sine of beta by 2. So what about beta? Number of slots per pole for phase. So number of slots here and this one, and number of poles here 16 and pole. So here this is 3 and this is number of slots per pole 144 divided by 16, that means 9, and beta equals to 180 by 9, that is 20. If you substitute in this formula m and beta, you will get the value 0.96. So this is 0.96. This is KD. So now if you substitute in this is the phase value. And next thing here, EL equals to line voltage equals to root 3 V phase. So after getting the phase value, you can substitute in this, you will get the line voltage value. And next thing here, next problem, find the no load phase and line voltage of star connected 3 phase 6 pole alternator which runs at 1200 rpm having flux per pole of 0.1 Weber. Next, it has stator slots, 54 slots and double layer winding. So each coil has 8 turns and coil is 1 volt slot. And next here, KC value equals to, here it is short pitched by 1 by 9. So here 1 by, each coil has 8 turns and coil 1 slot. So total 1 by 9. So 180 by 9. So that equals to 20. So KC equals to cos alpha by 2. That value equals 0.98. And here F equals to 120, N equals to 120 F by P. So from this F equals to P into N by 120. P into N by 120. So that value equals to this one. So here 6 is the number of poles here, 6, and speed is 1200. So this one is 1200 and by 120. So 120. So this frequency is 60 Hz. And what about the number of slots per pole? Here number of slots here 54 and poles are 6, and that value is 9, and beta value angle is 180 by 9. So now here number of m equals number of slots per pole for phase. So now here 54 and number of slots and poles are 6 and phases are 3. Here this value equals 3. So from this you can determine the KD equals to sine m into beta divided by 2 and sine m into sine beta by 2. So beta equals to 20 and m equals to 3. If you substitute in this, you will get the KD value equals to 0.96. So now here same thing here, Z equals to here previous problem. This problem is same as similar to this previous problem. Only these numericals are changing here. Z equals to 54 number of slots and 8 coils by 3. So 144, and total number of turns 144 divided by 2 and 72. Here this frequency value is 50 Hz, and next here if you substitute in this, so Kc equals to 0.96 this one, and Kd equals to 0.98 this one, and 0.96 for Kd, and 60 is the frequency, and 0.1 is the flux value, and number of tons here T equals to 72. So this is 1805 is the phase voltage, and EL is the line voltage, root 3 into 180 this 1805. So 3125 is the line voltage. Next problem, the stator of 3-phase 16-pole alternator has 144 slots, and there are 4 conductors per slot and connected in 2 layers, and the conductors of each are connected in series. If the speed of the alternator is 375 rpm, and calculate the EMF induced per phase, result and flux in the air gap is 5 into 10 power minus 2 webers per pole, sinusoidally distributed. Assume the coil span is 150 electrical. So now here 180 minus 150, that is alpha equals to 30. Cos 30 by 2 is the pitch factor, that one 0.966. And next, what about the number of slots per pole? Number of slots per pole 144 by 6, and number of beta equals to angle, that 180 by n, that equals to 20, and m equals to number of slots per pole per phase. So 144 16 by 3, that value equals to 3. So now we know very well this formula, KD equals sine Bm into beta by 2 by m sine beta by 2. Next, this one sine 3 into 20 by 2 upon 3 sine 20 by 2. So this value equals to 0.96. So now what about the frequency value? Ns equals to 120 F by P, and F equals to Ns into P by 120. So now here, so P is 16 and N is this one speed 375 and 120, this value is 50 Hz. And number of slots per pole, here pole for number of slots per phase is 144 by 3, 48, and total number of conductors per slot is 4, and number of conductors in series per phase is 48 by 4, 192, that value. Turns per phase is by 2. So now 192 by 2, this is 9. So now we know this formula. So this is the induced EMF. E phase equals to 4 into Kf into Kc, Kf into Kc into Kd, pitch factor, this one. And next, this one is the frequency, and this one is the phi, and this is the T. So now here, this one is 1.11 into 0.9669 frequency, and this is the flux, and these are the number of conductors here. So number of conductors here. So now final value is 988 volts. A 4-pole 3-phase 50 Hz star connected alternator, 60 slots, 4 conductor per slot, and coils are short pitched by 3 slots, and if phase spread is 60 degrees. Find the line voltage induced for flux per pole, 0.943 webers distributed sinusoidally in phase. So all the turns per phase are in series. So now here, so this one, m into beta equals to 60, this one, phase spread, and m equals to this 60 divided by number of slots per conductor per slot and phases, that equals to 5. 5 into beta equals to 60 and beta equals to 12 degrees. So if you know the beta and this one m equals to 5, then you can determine the distribution factor KD equals to 0.957 and alpha equals to 3. So now here how we will calculate the 3 slots are short and 3 by total number of conductors are 15. So now here 15 3 by 15 and into 100. This is alpha and alpha equals to 36 cos alpha by 2, that means 18, cos 18 equals 0.95. And now total number of tons. How we will calculate the total number of tons? First calculate the total number of conductors, and total number of conductors equals to total 60 slots and into total 4 and by 3, and that is total conductors 8 and tons equals 80 by 2. So now this is the phase, and this is a KF equals to flux per pole. This is the 0.04, and here KF equals to 1.11. So now here this is the formula. This is KF, KC and KD, frequency, flux, and this is the turn. So now this is the E phase voltage equals to 7613 volts, and this is line voltage root 3. Line voltage equals to root 3 into V phase that equals to root 3 into V phase, 7613 into root 3, that value equals to 13185 volts. So now here a 4-pole 50H star connected alternator has 15 slots per pole and each slot having 10 conductors. All conductors of each phase are connected in series. The winding factor is 0.95. So when the running on no load for certain flux per pole, the terminal EMF is 18 volts. So if the windings are lap connected in the DC machine, so what would be the EMF between the brushes with the same speed, same flux per pole, and assume the sinusoidal distribution of flux. Here KF is this one. Sinusoidal means that form factor equals 1.11 and KD equals to 0.95. This one KD equals to 0.95. This is, and KC equals to 1 for full pitch winding, and frequency equals 50 Hz, and EMF for phase is 1825 by this one 1825 by root 3. So now here number of slots, total number of slots 15 into 4. Here total number of slots 15 into 4 here, and total number of slots per phase that equals to 60 by 3. So now this is next number of tons per phase 20 into this 20 into 10 by 2, that equals to 100. So now here you can calculate. This is the EMF per phase, E phase, and this is 4.44, this one, and 1 full pitch KC, this is KD, and this is the flux, and this one is the frequency, and this one is the T. So from this you can calculate the flux per pole, and next here that value equals to 49.97. So now here EG equals to, so this is for alternator AC generator for 3 phase, and this is for this. So for AC generator, so here we know very well this one, flux value and speed is same, Z equals to 600, and next speed is 1500 RPM from this formula, and if you substitute in this you will get the, this is armature conductors and this is for lap connected. So this is Z equals to EG equals to Z and 5 by 60 into P by A. P number of poles, A is the number of parallel paths, A equals to P for lap winding, and Z is the number of conductors, N is the speed, and phi is the flux. And here, so this is the speed, this one is the total number of conductor, this one is the flux, and here P, A, and this one. So here EG equals to 750 volts. An alternator open circuit voltage 360 volts at 60 Hz when field current is 36 amperes. Neglecting the saturation, and determine the open circuit EMF when supply is 40 Hz and field current is 24 amperes. So we know very well this E phase equals to 4.44 into F into Kc into Kd into next phi m into T. So T is fixed and Kd Kc is fixed and phi in phi 1 and phi 1. So this is directly proportional to the E is directly proportional to the phi into F. So E1 by E2 equals to phi 1 by phi 2 and phi F1 by F2. So now here E1 by E2 here. So now here E2 you need to calculate here IF1 IF2. This is IF1 IF2. So now we know where 3.66 and this one, and next 60 here 60 Hz and another one is a 40 Hz and first voltage is 360. So now here E2 equals to 160 volts. Calculate the RMS value of induced EMF per phase 30 pole 3 phase 50 Hz alternator with 2 slots per pole per phase and 4 conductors per slot in 2 layers. The coil span is 150 degrees. Flux per pole has fundamental that value equals 0.12 Webers. So 20% third component. And next here coil span is 180 minus 150 that equals to 30 degrees is alpha. So now here 180 minus 150 that is alpha equals 30. Kc equals to cos alpha by 2 cos 30 by 2 means 15 0.966 and m equals to 2 here. This is slots per pole per phase. So already given, and next here, so now here beta equals to 180 by 6 here. So number of slots per pole here 6 here, that is 30. And next Kd equals m equals to 30, m equals to 2 and beta equals to 30. So now that value equals to 0.966. So Kc and Kd same value, but formulas different. Now Z equals to 10 into 2 into 4. So this 10 into 2 number of slots into 4 number of conductors. 10 into 2 into 4, that value equals to 80. Total number of turns equals total number of conductors divided by 2, that equals to 40. So now fundamental EMF. So now here, so we know this formula 4.44 Kc into Kd into F into phi into T. So phi value is this one and T value is this one, and Kc Kd we calculated. If you substitute in this, you will get the value. The EMF for fundamental is 995. So for third component means here third harmonic component case, here add same procedure, but here in the previous case here that value is harmonic, so only 1, but here substitute here 3. So now here cos 3 into 30 by 2 cos of 45 equals to, so everything is same. So here it is 1, here it is 3, this value is this one, this value is 0.707. And this formula is also for third harmonic. So sine m into n, this is the harmonic factor, and beta by m into sine m n beta by 2. So now here n equals to 3, substitute in this. So here you will get the same 0.707. And f equals to frequency, f2 equals to same third harmonic. So first one is this one, is second one this one. So third harmonic. So now this for this case also 50 into 3 150. And next here flux is 20%, 1 by third and 20%. So now here 1 by third 0.02 into this one. So this value equals to 0.08 Webers. And next calculate this is the Kc Kd, and this one is the frequency and this one is the flux, and number of turns are fixed, and that value equals to 106 volts. And E for phase equals to E1 square plus E3 square under root. If it is a fifth harmonic, you can add that one plus E5 square also. This is 0.995 whole square plus 106 square. Because of this harmonic value, this value is reduced. A motor generator set used for providing variable frequency supply consists of 3-phase and 10 pole per phase synchronous motor, 24 and 3-phase synchronous generator. The motor generator is said 50 Hz supply, 3-phase supply. 6 pole, a 3-phase induction motor is electrically connected to the synchronous generator, runs 5%, and determine the frequency generated voltage and speed. So we know this one. So synchronous motor equals to NS equals to 120 F by Phi. 120 F value. What about F value is, and this one, and P equals to, here P equals to 10. So that value equals to 10 volts, and that value equals 300. So now here 300 RPM. So this 300 RPM frequency and generated by 24 this one. So 1 to 24 poles, and next here this one equals 300, and this is 120 Hz. 120, that equals to 60 Hz. Synchronous speed of 6-pole induction motor fed from 60 Hz. So this 60 Hz 120 F by P, 6-pole 120 RPM. So now 5% slip means, so that value equals to 1 minus slip into speed. So that equals to, that value equals to 1 minus 0.05, that value equals to 1140 RPM. So further frequency of currents equals to slip into 0. And this one 60, 3 Hz. Find the no load voltage of star connected 4-pole alternator. The following: flux per pole is this one, 0.12, and slots per pole for phase 4, and conductors per slot 4, and 2 layers winding with coil span 180. The number of total number of slots here 4 into 3 into 4. So 3 phases and 4. So 4 poles, and next here number of slots here, conductors per slot, and 4 into 4 into 3 phase, and coil span is 15 degrees electrical, and next here total number of conductors 48 into 4, and next here that equals 190T, total number of turns by 2, 192 by 2. So T equals to Z by 2. So now here total number of turns in series, total here 32. So now here that is 32. So now here 60 degrees phase spread means this is KD. Here 60 degrees phase degrees. Here this is KD. We are calculating KD equals to, this is here 15 degrees slot, which 15 into M equals to 4. So 4 into 15, that is 60 by 2, and 15 by 2, that is the 7.5, that value equals 0.975, and Kp equals to cos 15. So that value equals 15, that value equals 0.96 for 50 Hz. And next thing here, this is the formula, this is the frequency, and this one is the Kc, Kd, this is the Kc, and these are the number of turns, this one T value, and this one is the flux, and this one is the frequency, 798. So now here, so line voltage equals to √3 into V phase, that equals to this one. So line voltage equals to this one. I hope all these problems are clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.